State the algebra of the continuous function and hence prove that a polynomial function is continuous at every point. Now solution: the algebra of a continuous function. Let f and g be the real valued continuous functions defined on the neighborhood of a point C. Then first, alpha f is a continuous at C, alpha is a constant. Second, f plus g and f minus g are continuous at C. Third, f into g are continuous at C. And fourth, f upon g is continuous at C provided g of C not equal to 0. The converse of second, third and fourth are not true, that is f plus minus g and f into g or f upon g may be continuous at a point C without f and g being continuous at the point separately. The result, second and third, may be extended to any number of the finitely may be the functions. For example, f, g, h, so on, u are the continuous functions at a point C of their common domain. Then the functions f plus g plus h plus so on plus u, f minus g plus h plus so on minus u, and f, g, h, so on, u are also continuous at a point of C. To prove that the polynomial is a continuous function at each point, let f of x equals to a0 x raised to power n plus a1 x raised to power n minus 1 plus so on plus an, where a0, a1, a2 and so on an are fixed real constants. Let g of x equals to x. Then we first prove that g is a continuous at each point of its domain. Let C be any point of its domain. Then g of c equals to c. Modulus of g of x minus g of c is less than epsilon implies that x minus c is less than epsilon. Here delta equals to epsilon, thus given epsilon greater than 0, there exists delta equals to epsilon greater than 0 such that g of x minus g of c's modulus is less than epsilon, where modulus x minus c is less than delta. Thus g of x equals to x is a continuous at point x equals to c. Then by algebra of continuous function, the product function g raised to power n x gx whole raised to power n x n x raised to power n equals to x into x into x so on, g raised to power n minus 1 x equals to g x raised to n minus 1, g of x into g of x and so on, g of x n minus 1 factors equals to x raised to n minus 1 etc. are all continuous at x equals to c. And by 1 the functions a0 x raised to power n, a1 x raised to power n minus 1, a2 x raised to power n minus 2 and so on are also continuous, and hence the sum of the functions f of x equals to a0 x raised to power n plus a1 into x raised to power n minus 1 plus a2 into x raised to power n minus 2 plus so on plus an will be the continuous at the point C. Since C was any point of the domain, therefore the polynomial function f of x is a continuous at every point of its domain.